Exactly. So we have to shade this side. For this one, if we are focusing on the Z, we want to calculate for the stress at Z, we have to shade this side. Okay. Then once I'm done shading it, you will see the area well. You see the area you want to talk about so that you don't just confuse it for any side. Exactly. So the area I have shaded, that is the area I'm talking about. Okay. So in this case, the area of our Z is just going to be hot. It's just going to be 400 times 30. 400 times 30 in this case. 400 times 30 in this case. Okay. So let's quickly go and do that. So the area Z now is just going to be hot. 400 times 30. And then the load is what? 180 kilonewton. So let's put that down. 180 kilonewton. So that is 180 times 10 exponent 3. Okay. So at this point, you can just quickly punch it and tell me the answer. Okay. So let's all do it together. That is 180 times 10 exponent 3 all over 400 times 30. And that is going to give you 15 Newton per millimeter squared. 15 Newton per millimeter squared. Exactly. 15 Newton per millimeter squared. So now that we are done calculating for the hot, let's say our stress at X, stress at Y, stress at Z, we can just put it into the formula and then we are good to go. Okay, so let's just quickly put it into the formula and let's wrap up for the day. Exactly. So we can say that finally we can just put everything into the equation since we don't have our parameters. So we can say that what finally, comma. Then we can just use a different color pen, and that is what finally. So finally we can say that what our volumetric strain. Finally we can say that our volumetric strain is equal to what? The 1 over what? Elasticity. And the 1 over, or better still, we can even still write the formula again, okay? So that everyone can be sure of what we are doing. Okay, so we say that this is the stress at X minus the stress at Y. Okay. Plus the stress at Z. Exactly. Plus the stress at Z. Bracket close. All multiplying 1 minus 2 mu. Okay. All multiplying 1 minus 2 mu. So let's just substitute our values into this and see how best we can become history. So that is it. Everybody, let's quickly do this individually. You can punch your answers in the comment section. I'll review them for you. And that is our stress at V is going to be equal to 1 over what? Elasticity. The elasticity given to us was 2 times 10 exponent 5. Okay, all multiplying. Good. Our stress, our stress at this, how did we get? Our stress at X, we had 20, okay. Our stress at we had 50. Our stress at S, we had 50. Our stress at Y, we had 20, and the other one was 15. So our stress at X was 50. Good. Minus also our stress at Y. And then our stress at Y, we had 20. It was the last one that we had 15. That is the stress at Z. So we say that plus 15. Okay, good. Our Poisson ratio has been given to us already to be 0.3. So 1 minus what? 2. Then the Poisson ratio. Let's go and check it again if we are not too sure. So that is the Poisson ratio over there. This is it over here. That is 0.3. You see? Exactly. So let's put it over there. 0.3. Okay. Exactly. Then I close this bracket nicely. So we can all point this into the calculator and we are going to get the answer for our volumetric strain. Take note that we are not done because the question is asking us to calculate for our change in volume. So after we are done calculating for our volumetric strain, now we can just go and calculate for our change in volume and then we are good to go. So everybody, let's all quickly point this together. Let's all quickly point this together.
So I've done it. I don't know if it is correct.
Exactly. So we are supposed to get 9 times 10 exponent negative 5. Yes, that is the answer you are supposed to get. And it has no unit because it's volumetric strain. So that is, so exactly. So we are saying that after multiplying the whole of this, you are supposed to get 9 times 10 exponent negative 5. Okay. 9 times 10 exponent negative 5. Exactly. It has no unit. Okay. So after getting this, now we can say that finally we can now go and calculate for our hot change in volume. Okay. So finally, this is where we are going to calculate for our change in volume. Then we are done with the work. So finally, let's calculate for the change in volume. Change in volume. So that is our change in volume, and we are good to go. We said somewhere that if the volumetric strain, okay, we said somewhere that the volumetric strain also has a formula of what? Change in volume over what? Original volume. Okay, so if you want to calculate for the what? Change in volume, then it means that we just have to make change in volume the subject. And take note that this is change in volume over here. Okay, that is delta V. So that is our change in volume. Don't get confused. So finally, we can say that our change in volume over here is equal to the volumetric strain times the volume. Okay, so back from whatever we worked so far, let's just put our parameters into this and then we can calculate for our change in volume. Then I can say that we are done solving the problem. So our volumetric strain we calculated for over here. This is the answer we had. Okay, so let's put it over here. That is 9 times 10 exponent negative 5. Okay, times the volume. Okay, so the volume we calculated for, let's go and look for the volume. And we realize that after calculating for the volume, we had 120 kilo millimeter cube. Okay, so let's just put that inside here and then let's wrap up. So that is times what? 120 times 10 exponent what? 3. Okay, millimeter what? Cube. And if you multiply these two, it's going to give you an answer of this. Okay, so finally, this is going to be our final answer. And our final answer is going to just be equal to 10.8. Okay, that is if you multiply 9 times 10 exponent negative 5 by what? 120 times 10 exponent 3. You are going to get 54 over 5. That is the same as what? 10.8 millimeters cubed. Okay, so that is 10.8. 10.8 millimeter cube. Millimeter cube. Okay, exactly. So that is it. This is the answer we had. Let's go and compare it to the standard one. You see that the standard one to this is the answer we are supposed to get, and that is the same thing we're having over here. Take note that this one, this is supposed to be millimeters. Okay, so this is millimeter cube. This is millimeter cube, as simple as ABC. So we had 10.8, and we are just supposed to get 10.8 millimeter cube. Okay. So on this note, my name still will remain Megabyte the physicist. Don't forget to see me in groups, in person, in case you find any challenges related to whatever we have learned so far. Also, don't forget to like the videos, share, comment, and then subscribe. Okay, for more. The last but not the least, I'll urge each and every one of us to take our studies very, 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 very serious. Okay, don't wait until you want examination to be due before you start learning. Learning is just like you being, if you say you're a student, it's just like you being a footballer. Each and every day you have to be doing training. Okay. If you're a footballer and you don't do training before going to play match, you realize that you won't perform very well. So each and every day your calculations have to be your what? Training, your daily training. Each and every day you have to try and solve something so that with that, your brain is going to be trained. And any question that you see, you can be able to do something at least, even if you are not able to solve all. May God richly bless you all for your time. Have a wonderful day. Thank you all very much. Bye bye.